So now that we know how to reduce fractions and multiply fractions, we're going to take it a step further, and we are going to now divide these. So just remember, these are just big fat fractions. So I've got this fraction divided by this fraction, which means what we need to do is keep this, change this to multiplication, and then flip this one. So I'm going to rewrite this as q squared minus 9 over q squared plus 6q plus 9. Do not reduce your q's and q squareds and 9s and all that. We've got to change them into multiplication problems first. So this is now multiplication, and this denominator will now become my numerator, and the numerator will become my denominator. And now I can factor. So this one, instead of a subtraction problem, is the difference of two squares. So this is going to become a q plus 3 and a q minus 3. Okay, this denominator, I need two numbers that multiply to 9, that when I add them together I get a 6. So that's going to be a q plus 3 and a q plus 3. So hopefully you'll already see some stuff that can be reduced, but it's a secret, so I'm not telling you yet. All right, so two numbers that multiply to negative 3, so your signs are different, that will subtract to 2 are going to be 3 and 1, and your 1 will be negative, so positive 3 and negative 1. And then on this one, two numbers that multiply to negative 3 that subtract to negative 2, which means your 3 is negative and your 1 is positive. So I've got a negative 3 and a positive 1. So now I've got this times this times this times this, this times this times this times this. So this is just one big fat fraction again. And now we can go in, after I find my red pen, and start reducing. So I've got a q plus 3 over a q plus 3. So any number divided by itself is 1. I've got a q plus 3 and another q plus 3. So any number divided by itself is 1. I got a q minus 3 and a q minus 3. So any number divided by itself is 1. That leaves me with a q minus 1 over a q plus 1, which is two completely different numbers. You cannot reduce the q's because you just changed it back into an addition-subtraction problem. So your final answer is going to be q minus 1 over q plus 1. And that's as far as you can simplify it. So don't reduce it. Now that it's back into addition-subtraction across the top and bottom, you're stuck. So just to give you an idea, if I were to substitute in a 10 for q, there's an infinite number of numbers I could substitute in. But let's just say I grabbed a 10. Then 10 minus 1 is 9 over 10 plus 1 is 11. So even though they share the q, the minus 1 and the plus 1 changes the value. Okay? So it would end up being a 9 over an 11, which does not reduce. So there you go. All right, the last couple examples in Module 9.1 are going to be, and I'm going to write this kind of weird, we are going to add and subtract fractions together. So I've got a p plus 3 over a p minus 2, and I'm going to add that to a p minus 3 over a p plus 1. And notice I just left some room because I need a common denominator. So what do we do for a normal common denominator? I would see all of the representatives and I could multiply them together. So in that case, my common denominator would be a p minus 2 p plus 1. That's what I want to get, is a p minus 2 times p plus 1. That would be my common denominator. So this one has, side note, you cannot clear this of fractions because there's no equal sign. So I'm stuck in fraction world. Okay, so I've got a p minus 2. I need a p minus 2 p plus 1. So let me write it this way actually. If I'm going to get a that was lovely. If I'm going to get a common denominator, I need a p minus 2 p plus 1. I cannot say those words. P minus 2 p plus 1. That's what I need. So if I'm going to move from this fraction to this fraction, what am I missing? I'm missing the p plus 1. So I'm going to multiply the top and bottom of this by p plus 1. Why am I randomly allowed to do that? Because any number divided by itself is 1. So I'm just multiplying this fraction by 1. I am changing what it is. Or sorry, I'm not changing what it is. I'm changing what it looks like. So this numerator now becomes p plus 3 times p plus 1. Okay, so I'm on my way. Don't reduce that because you'll end up with this back. We're trying to get a common denominator so we can add these together. So on this one, I got the p plus 1. What am I missing? I need the p minus 2. So multiply by p minus 2 on top and bottom. So really, I'm just multiplying by 1. I'm not changing what this fraction is. I'm just changing what it looks like. So my new numerator on the second fraction is going to be p minus 3 times p minus 2. Don't reduce it or you're going to end up right back here. So now what do I have? I have a common denominator of, so I'm going to write this thing over my common denominator of p minus 2 times p plus 1. Okay, so just like if I were adding fractions together, basic fractions, if I had a common denominator, I wouldn't change the denominator. I would just combine like terms on the numerator. So I planned poorly, which means I am now going to combine like terms after I expand. So this numerator is p minus 2, p plus 1. Now I just got to add the two numerators together. I think I just said that backwards. My denominator is p minus 2, p plus 1. Now I've just got to add the two numerators together. So in order to do that, I'm going to go ahead and FOIL these out. So I have a p times a p is a p squared. A p times 1 is p. A 3 times p is 3p. And then 3 times 1 is 3. So that is this first portion of the numerator. So that is a p squared plus 4p plus 3. Okay, so I'm already writing it over my common denominator. Now let's do this one. I've got p times p is p squared. P times negative 2 is negative 2p. P times negative 3 is negative 3p. And then negative 3 times negative 2 is positive 6. So that gives me a p squared minus 5p plus 6. And now combine like terms. How many p squareds do I have? I have 2 p squareds. So 2 p squareds. How many p's do I have? 4 p's plus negative 5p is negative p. And then 3 and 6 is 9. So plus 9 over p minus 2 times p plus 1. So our last thing that we could do is see if we can reduce this final step. So in my head, I'm going to multiply these together. I've got a 2 times a 9, which is 18. Are there two numbers that multiply to 18, same sign, that when I add them together I get negative 1? No. So I'm effectively done, which means I can go ahead and multiply out this bottom. So I've got a 2p squared minus p plus 9 over p squared, and I'm out of room. 1 times p is p. P times negative 2 is negative 2p, so when I combine like terms, I get negative p, and then negative 2 times 1 is negative 2. Don't reduce the p's, don't reduce the p squareds. This is now multiplication, or sorry, addition, subtraction over addition, subtraction. So let's try it again. We have, wait, I'm looking for a fresh paper. Still looking for a fresh paper. All right, we have the final example is s minus 1. These are not 5s, these are s's. Over s plus 1 minus, so again, I'm going to leave some room over here to get my common denominator, 2s plus 3 over 2s plus 1. So what is my common denominator? Well, I need a s plus 1, and I need a 2s plus 1. So my common denominator is going to be the product of those two denominators. That's my common denominator. Okay? So for this one, I've got the s plus 1. What am I missing? I'm missing a 2s plus 1. So multiply top and bottom by 2s plus 1. Okay? So I am going to take this, and I'm going to put my answer in parentheses. And we'll do minus. Perhaps I should make all of my colors match. What fun is that? Okay, so I'm going to multiply. I've already got my common denominator here. So I'm going to go ahead and multiply this out. So I have an s times a 2s is a 2s squared. S times 1, okay, is 1s. Negative 1 times 2s is negative 2s, and then negative 1 times positive 1 is negative 1. So this one, I need my common denominator. I've got the 2s plus 1. What am I missing? I'm missing the s plus 1. So I am going to do top and bottom times s plus 1. So leave your common denominator. I have a 2s times an s is a 2s squared. 2s times 1 is 2s. 3 times s is 3s. And 3 times 1 is 3. All right, so I'm going to very, very carefully, I'm going to simplify inside the red first, simplify inside the blue, and then I'm going to change signs. But all of this is still over a common denominator of s plus 1 times 2s plus 1. So when I simplify in the red, I get a 2s squared. 1s minus 2s's is a negative s minus 1. And then you know what? I might just go ahead and distribute this. So a 2s squared, change the sign, gives you a negative 2s squared. 2s's and 3s's is 5s's, change the sign, so minus 5s's. And then a 3, change the sign, gives you a negative 3. There we go. Now, since I went ahead and changed the signs, so look at this part. It was a positive 2s squared, now it's negative. It was a positive 5s, now it's negative. It was a positive 3, now it's negative. So I distributed that negative. Now just do what the signs say. So 2s squareds minus 2s squareds is no s squareds. A negative s minus 5s is negative 6s's. A negative 1 minus 3 is negative 4, and that's going to leave me with an s plus 1 over a 2s plus 1. That's your common denominator. So is there any way that I can reduce this? Okay, if I divide out a negative 3 on the top, that would give me a negative 3, which is a 2s plus 2. Is that right? Hang on, my brain just melted. If I pull out a negative 3, that leaves me with a 2. I can't pull out a negative 3. That's why that didn't work. That's a 3. It's like that, it's not right at all. I can pull out a negative 2. So when I divide by negative 2, I get a 3s. When I divide by negative 2, I get a positive 2. Does that match anything down here? No, it doesn't. So I just wasted my time. So I'm going to go ahead and finish this thing out by saying I've got a negative 6s minus 4. And now I'm going to distribute down here. So s times 2s is 2s squared. S times 1 is an s. 2s times 1 is 2s's. 1 times 1 is 1. So my final answer is a negative 6s minus 4 over 2s squared plus 3s plus 1.